All right, good morning, everyone. And like Randy said, we're gonna do a little digging into MBA MaxT Minty guidance, and we'll give you a little motivation behind this. So, we had done a little bit of this MaxT Minty guidance stuff back in February during there was that cold outbreak through the Central Plains, and kind of took a look at this, dug into it, and I did at that point we did a little cross regional sign share amongst all the and sent it out to all you and at least in CR and with some of the same people that are on this presentation. But now we looking ahead to this later week and the weekend. There's a warm spell coming for a good chunk of the upper Midwest, and that it kind of got brought up again. And so let me just jump right in here and kind of show that. So for today's talk, here's sort of how we've got things laid out. We're going to do a little looking at the ECMWF EFI, we've kind of covered in the last couple of live forecast discussions. Take a look at the MBM MaxT Minty plots and viewing them as well through model certainty output. Talk a little bit about the MBM MaxT Minty deterministic and probabilistic forecasts, how you might use them as a forecaster, and then how to integrate those into your AFD and messaging, and then we'll have some open discussion at the end. So kind of again a review here on the ECMWF Extreme Forecast Index and the shift of tails. Again, it's one of my favorites. It's just purely the European ensemble, but it's a nice situational awareness overview of anything that's going to be kind of on the potentially extreme end. The EFI is just measuring here, as I stated, the amount of extremity in the ensemble relative to its model climate, which is about a 20-year period. So again, you run the model backwards for 20 years, and you come up with various indices here that range from 0 to 1 for the using current data. And we'll actually show an example of the EFI CDFs here in just a second. And then there's the shift of tails, which helps to really amplify where there are some really extreme members within the ensemble that just the EFI by itself can't account for, because the EFI is capped at that 0 to 1 range. So let's take a quick snapshot, because if you look at this at the ECMWF EFI, there's a nice warm spell again showing over the upper Midwest. And if we take Madison for an example, there's EFI CDF there on the left. You've got various lines there. Each line represents a forecast. You can actually look, kind of gives you a dprog dt, if you will. And you can see all of the forecasts from all the different ensemble members are pointing to an above normal situation. And if you look at that the top 10% is pretty much similar to the whole entire distribution going all the way down to 0. So that's why we didn't see any really shift of tails highlighted over Madison. And on the right, if you look at the information from Weatherbell, this is the looking at Saturday, the box and whiskers there gives you 25th to 75th is ranging from 80 to 80, 83 or so, and then your maximum there is about 86. So from a climatological perspective, I do have some information there for Madison. Normal high 71, so yes, you're above normal, and that's again what the CDF is, the EFI CDF is showing. But the record high is 92, and we're nowhere near that in the European ensemble. And that's another reason why that shift of tails really doesn't show up on the graph or on the previous chart. So one of the things I'm going to ask you all as we leave the EFI and jump now into the MBM is how many of you have viewed the MBM MaxT Minty percentile data, and you have some a website up there at the top that you can utilize. There's also a text message, and again, this is one that's a select all that apply. And there's just no right answer. This is just kind of a curiosity: is how are people viewing these this percentile data? And I'll give just like about 2 minutes for this. I know me personally, I'm looking at it probably through all three items there, the 1D viewer, the what's up, and the and GFE. So, but I'm curious to see what everybody else has. All right. So at least up to this point, it seems like there's a predominance through the 1D viewer, but still quite a bit through D2D and GFE. So that's cool. So I am going to lock the responses right now. So thank you all for responding. So now we're going to toss this over to John, who's going to talk a little bit about medicine for the MBM MaxT and MinT plots.
All right, thank you, Andy. Can you hear me?
I can.
All right, beautiful. So I suppose I'm basically to blame for kind of inspiring this talk, and obviously serendipitous that we had a cancellation, and we're talking about this today. Is I was just getting myself my bearings for the week and taking a look at what was happening on Monday, and took a look at the box and whiskers here from this is the 1D viewer from the WASUP site, the output here, and it struck me very quickly about what I was seeing for Friday, Saturday, and Sunday when it came to the high temperature box and whiskers for Madison, and then the dot being the deterministic NBM forecast. And a couple things struck me, and Andy kind of set the table pretty well here, is that for one, there was a pretty big separation between the deterministic and then the probabilistic NBM. Two was very tight on the distributions, especially if you look at Saturday. The confidence interval from the 25th to 75th percentile, the 50% confidence interval was like 3 or 4 degrees, and that's at day 6, 5, 6. And then if you looked at from the whisker side, I think I believe it's 10 to 90th percentile. Correct me if I'm wrong, Andy, but the 80% confidence interval, for this pattern was just maybe 8 degrees, which again for day 5, 6. Spring season, that's a head scratcher. It leads me to think, something's going on here. I got separation between the deterministic NBM. My probabilistic NBM is really compact. It's a very tight range. And then the third thing, and I often have to remind myself here, I'm still a transplant here to southern Wisconsin, grew up in Missouri, lived in Jackson, Mississippi. So 90s in May weren't a big deal. That was called life. But I remember, I'm in Wisconsin, so it's like, wait a minute. Even late May in Wisconsin to get into the 90s is pretty rare. And as Andy already passed along, record highs are like 91, 92 in the Madison area, and it's somewhat similar for Milwaukee, usually a degree or two lower, just because there's the ice box of a lake just in the shadows of Milwaukee themselves. So it's like, wait a minute, what's going on here? So all of these things led me to look a little bit deeper. I really, for folks that have kind of gone through these discussions before or joined into the Science Circle chats with Southern Region that they host every Thursday, I started applying what Chad Gravel started talking about. Well, what's my conceptual model? So we know we got a building ridge. We know we've got a ridge of high pressure building in. We know we've got deep warm advection, warming temperatures at 925 and 850. So we should be warm. We should be warmer than average. But wait a minute, the entire probabilistic, the 100+ members of the ensemble from the probabilistic NBM are saying I should be around or exceeding record criteria here, especially on that Saturday. So we need to dig in more. So we're not necessarily to the point where it's like, if I'm in the forecaster's seat at the office, I'm in front of GFE, what am I doing? It's not that I'm making a change, it's that I got some questions I need answered. So the first thing I did is I pinged Jerry, because this is what I do every day. And Andy, if you want to go to the next slide, we'll have Jerry kind of divulge what he showed me. So I had him run model certainty, because I was at home and I don't have access to AWIPS from home, but Jerry does. So he ran this image, and Jerry, why don't you go ahead and explain what you've got here?
Yeah, so actually this image was done from today, but it's very similar to the image that we saw earlier in the week. So the idea here is through model certainty, and this is somewhat new to model certainty. It's new to the time frame of when the MBM percentiles became available to us in GFE. And when that happened, I added functionality so you could actually see what the MBM box plot would look like and compare that to what model certainty is seeing. And I did this for a number of reasons, mainly to see if we could actually utilize the information that model certainty is providing to give us some insight into what might be happening to the MBM and its probabilistic space. So when you're looking at this, these box plots here, there's a few things that just sort of jump out at you. It's, especially if you're looking in that Saturday time frame, you're getting into a bimodal distribution where a lot of the raw models are sort of on this cold side of the distribution, and a lot of the bias corrected models are on the warm side of the distribution. That signal is there, but really on that Saturday, you really have a strong bias corrected signal, bimodal signal. And you can also see that you have that triangle, the green triangle, that is showing where the MBM, the deterministic MBM is, and you can compare that to the green box plot and see in most cases, it is actually below that 10th percentile. So, this really does, I think, in this situation, help try to explain somewhat what is going on in this probabilistic, data and why it's happening. So I'm going to jump to the next slide here and sort of propose a question to you all. And, why is there this big difference between the MBM probabilistic and deterministic forecasts? What are your initial thoughts? So basically, is it a bias correction issue? Are the bias correction driving up the probabilistic models? But keep in mind, bias correction applies to both deterministic as well as the probabilistic data. So that's a question. Is it membership? What's going on with the membership of the deterministic versus the probabilistic? Could there be some topographical issues? And and this is a fine answer too. You just don't know. I mean, we don't have a lot of information as to what is going on in the MBM. We're trying to learn more about it. But I don't know is, in my opinion, a perfectly fine answer. So we'll give you a couple minutes here and go ahead, and then from there we'll jump into a little bit and see if we can help you try to understand, what could potentially be going on here and why we're seeing these big differences. I think we're starting to sort of lock into, basically what I expected to see. I'm actually happy to see a lot of people are saying, I don't know, because that means you're at the right place. That means that you're coming here to try to see if you can help understand what's going on with this. I think bias correction is a very strong answer. Membership is also, and you know what? Sort of topographical I threw in there is, another idea here, and it can relate. There is some bias correction going on in the MBM, and it's being done to try to get it down to some of the topographical features. So you could also even have answered all of the above, but we'll dive more into that. And I think Andy's going to talk a little bit more about that in the next few slides.
Thank you, Jerry. So yes, we will move on to this. So let's dig in. How are these probabilistic and deterministic MBM forecasts calculated? So let's start with the probabilistic. So the probabilistic uses 171 members, individual model members for the first 24 hours, and it gradually drops off. And that's just because, you know, you've got models in that, like take like the NAM, that only goes out so far, the, you know, the SREV, HREV, you know, things of that nature, HER, that don't go out as far. So yeah, you're going to drop the number of members farther out in time. There is a bias correction. It's pretty basic. We're just going to look at the previous 72 days of the model archive, and it's applied to every member. And there is no raw model guidance included within the distribution. Everything is sort of, you know, bias corrected. And the bias correction is really, it's kind of Jerry was alluding to, it's a downscale process. More than is just completely bias correction. It's trying to, because when you bring all these ensemble members in, they're all at lower resolution than what we see of the deterministic models in AWEFs. And so we're trying to, the MBM's trying to bring that down and help, you know, give you that, and it's downscaled to the NDFD grid. So you get the 2.5 kilometer look. And again, it's done using the IRMA as that bias correction. So the problem is that we have the transition seasons where you can result in large, you know, kind of big changes from where you were to where you are now. So like, you know, spring to summer, the probabilistic values will probably run warm because the past 72 days have been cold. And then you flip it around the fall, and during the fall to winter side, the probabilistic values are going to run cold because you've been in a very warm period. Now let's talk about the deterministic. The deterministic uses 16 members. We're going to use deterministic models, again, like the HER, the NAM, and whatnot, and the ensemble means, not individual ensemble members. And they're dynamically weighted in the first 36 hours, and then you've got an additional, you know, 10 members after that, because again, we're dropping off membership. Here, we're going to use a Gagan model bias correction, so that you have some of the models are weighted, you know, are bias corrected more heavily based on the a certain period of the past, you know, 14 days or whatever, and then the beyond that weighting drops off, and we'll actually see that here in an upcoming slide. So the benefit with this approach is it allows for a quicker response to change in weather patterns compared to the probabilistic. But as you can see, given all this information, the probabilistic and deterministic are apples and oranges in the way that they're computed. So you have to treat each one separately. I think it's important to take a note here that the probabilistic grids or probabilistic stuff from the MBM is very new. It was introduced here with version 4. So this is something that certainly can evolve with time, and we're learning as we go with this, and we can probably go through and make some improvements. And I think there are some already scheduled for version 4.1. So I'm going to break into this individually so you can see this. So here's the components for MaxT and MinT from the MBM, the deterministic on the left and probabilistic on the right. With the deterministic, we also have weighting that occurs that goes point by point based on performance. And I've provided a link here and within the presentation, and that will get shared out, and you can see the various they have various samples to see how that MBM weighting is done for each of these various members of this, and you can see again that as you go farther out in time, the number of inputs drops off because the models just don't go out far enough. And then the probabilistic, same deal, but you see in there the individual ensemble members. Now we don't have all of the GEFs in there, because the GEFs upgrade occurred simultaneously with MBM version 4.0, and so you only have about 2/3 of the latest GEFs v12 going into the MBM version 4.0, but we do have a healthy amount of the European ensemble and some other ensemble information. Again, the bias correction, here's a kind of nice view of it. So the deterministic here on the left, it's kind of interesting to look at how bias correction is done. We have, the MBM's got its own approach, and it varies based on the time of year. During the summer months, it uses a different, what's called an alpha here, where in the summer months it weights more of the past like 2 weeks, comparison to what would happen during the fall, winter, and spring, where you're weighting almost equally what happened in the last like 2 weeks with the last 4 or so. You can see that with the slope of that red curve. When we create bias corrected grids in GFE, through the Boyce verify process, that's a very simple approach, and we maintain the same alpha for the past 30 days. So you just go straight. We're going to apply the past 30 days to the value to correct the grids. And there's actually a table here below that kind of shows what that percent influence would be if you were to use all these different sources. So then again, the probabilistic approach here, we use the QMD for bias correction, which is the same thing as done with precipitation, but again, it's a basic bias correction based on the previous 72 days of the model archive. So it's not as going into all these different things with different alphas, for example. All right, I'm going to pass this over to Ted and Vivek to discuss a little bit about utilizing this MBM probabilistic data and the deterministic with respect to the forecasts.
So yeah, thanks, Andy. This is Ted in Fort Worth, and what we discovered was kind of similar to what you're going through right now. Is we had a big transition in our season, so to speak, way back in February when we were starting to look at this probabilistic data more closely, and we saw the same thing, that the deterministics was well below where the probabilistics were. So we didn't really know what to do with the data back then, but we were learning on the fly pretty quickly. So now that you know why the data can look different, maybe it would help to also know whether you can do anything with this data with your forecast process. When you see that there's a difference, and what we noticed when there was the 50th percentile was much different than what the deterministic MBM had, it kind of was, I don't want to say it was a sign that we needed to do something with the forecast, but it certainly was a sign that we needed to dig a little deeper and figure out if there was a target of opportunity that was present. It might be a target of opportunity that's present where you need to change the forecast. It might just be a target of opportunity to where you need to message something because there's something going on. And so a couple of the things that I was telling the forecasters down here that they need to ask themselves when they see this big difference between the probabilistic and the deterministic data was, will the weather pattern be changing, so that using a different bias correction technique, i.e. the short-term bias correction technique, stuff that's weighted toward the short term, or a long-term bias correction technique, the probabilistic data, where the last 72 days are more weighted for that. So which one would be more accurate? And so the first time we really saw this stuff happen, we had a couple different types of events. The first one was the snow cover that we had in February in our deep freeze. The MBM deterministic was much too warm with the temperatures for about a week. We had a bunch of snow on the ground. And then as we got a few days out in the forecast, we were going to have our warm south winds return. It was going to melt the snow. And what we noticed with the probabilistic guidance was some 15, 20 degrees higher than the deterministic guidance from the MBM. And what it was is that the deterministic guidance from the MBM was basically saying that that snow was still going to be on the ground, that it still needed to apply that bias to lower all those temperatures, when in actuality, what we were going to was more of a normal pattern for us, so to speak, so that 72-day bias would actually would be better. And so the warmer guidance ended up being more correct. So forecasters seeing that warmer guidance were able to use the 50th percentile and actually make a really good forecast change 5, 6, 7 days out. The other thing that we saw was a downslope warming event. This was kind of just a one-off, sort of a, cold front coming through, and we got some downslope winds and some sunshine. What we noticed that the MBM probabilistic data seemed to do better with that than the deterministic data. Now, if you had downslope every day for a week, then obviously the MBM deterministic is going to learn about that, and it's going to start correcting its forecast to be better. So these were situations where we kind of had some one-off things occurring at some point during February and March months. The other question to ask yourself is there is a potential for a day for anomalous temperatures, but due to timing uncertainty, the spread will be skewed across the probabilistic MBM data. An example of what we saw here was we expected that we would have a dry line move into our area, and it was going to be hot behind the dry line. But we were 5, 6, 7 days out, and we couldn't actually tell which day that dry line was going to move through. It was going to be our first 90-degree day of the spring. So we were able to message that at some point Thursday, Friday, or Saturday, we were going to get to 90 degrees, but we didn't know exactly which day it was. And it was because the probabilistic data was all much warmer on those days, and the deterministic data was all kind of cool on each of those days, that we knew at one point one of those days was going to be warm, and that the other days would probably be closer to the MBM deterministic. But it was a messaging opportunity. It was a way for us to say we don't know exactly which day, so we're not going to change the forecast, but we know one of these days is end up being our first 90-degree day of the year. And so one of the things I love about the looking at the MBM deterministic data in conjunction with the probabilistic forecast is that if they are both very close to each other, it's a high confidence forecast, and it's kind of like a sign for me that we can go ahead and leave the forecast on autopilot. There's nothing really to dig in deeper there in those situations. So it's kind of a confidence builder that if you see both the MBM probabilistic and deterministic match, you can kind of say, all right, forecast can probably be left on autopilot in this case, and we can move on. I don't know if Vivek, my neighbor to the north, has anything that he wants to share, but those have been our experiences down here.
Hey, all right, thanks, Ted. Can you guys hear me?
Yes.
All right, awesome. Yeah, those are actually pretty similar cases that we had, up in Norman. One thing that I noticed with the deterministic NBM, and you probably dealt with this down in Fort Worth, Ted, is, when we have these shallow cold fronts a couple of years ago, ahead of these fronts, we have, a prefrontal torch where we get very warm temperatures ahead of the cold front. And, the deterministic NBM actually thinks, it's been, too cold and trends warmer, essentially. However, once that front passes, the short-term bias actually works against you in this case. And, the probabilistic may actually provide more utility here if you see that difference. So essentially, as Ted mentioned, if you see a big difference between that 50th percentile probabilistic and deterministic, it is, a potential target of opportunity. And, one other thing to consider is if you think, say, the short-term models like the CAMs are having a better handle on something, for example, one thing you want to consider is maybe the deterministic in the short term might have a little bit more utility because there are fewer inputs. So there's a bit more weight to those high resolution guidance for the MaxT and MinT. So if you think those models are doing better, the short-term models, you may want to use that because sometimes those global models, may wash out some features because all those global inputs are kind of weighted in with that probabilistic information. So, as a key point, as we mentioned earlier, is as meteorologists, we have to make sure we still use conceptual models, to essentially regional and sub-regional conceptual models need to be used to identify patterns for these high impact threats. And we have to understand how they can be used with the statistical meteorological guidance. In other words, when and how much to change that CDF for a potential target of opportunity. So that's all I got.
Yeah, thanks, Ted and Vivek. And I think now I'm going to pass it over to John to talk a little bit about this whole community. Ted and Vivek talked a lot about messaging. You may not have to adjust a forecast, but being able to message it. So yeah, I'm going to pass this over to John to talk a little about that.
All right, thanks, Andy, and thanks, Ted and Vivek. I'm really happy that you're able to join us today. So, the probabilistic NBM, as we see for temperatures in version 4.0, is new and it's somewhat in its infancy and it's evolving and we're learning. And I think that's one of the things that we take out of this today is that there are certain things we need to keep in mind about our tools. There are pros, there are cons, there are things to keep in mind. And ultimately what we're trying to do is you know, as we evolve with the NBM and learn more about it and learn more how to use it, is how we can take advantage of some of the data that it's providing to us. You know, so as I'll talk on the next slide, we don't have to go there yet, Andy. I'm going to kind of, like we've done with previous ones, kind of do a what would you include in the AFD, but it's also kind of your forecast process. So you know, one of the things you want to be able to do is talk about, okay, what's my conceptual model? How am I testing that conceptual model with this data? Where do things seem to be going off the rails, and where do things seem to make sense? In this particular case, it's a little unusual, and as was Andy described earlier, we have a feature of the probabilistic NBM where we get into situations like in the spring, where we've had a cooler pattern, bias corrections warming us up, but then that pattern does a 180. It flips on us. But the bias correction isn't going to change. It's just going to stay as what it was until it's trained over that period of time to become less and less. And that's what's going to be happening this weekend. The NBM is going to start that training process as we get through our changeable spring season and into summer. So we know that, okay, we know that the probabilistic NBM is going to be, you know, based on what Jerry showed us and showed us how much bias correction is influencing our raw models. It's going to be forcing things warmer. Now, does that mean that it's necessarily wrong? Not necessarily. We still have some questions to answer there. But the ultimate goal with this and trying to use this information is to try and change our language and how we change talking about these things. And Andy has on the screen here that recommendation of what we would normally say and what we would replace with. So if we do go to that next slide, Andy, I kind of culminate everything in there. Hopefully you've got, you have to kind of go in and out. Since this was all typed on the fly, I can't tell you how much fun this is to type this all in about 10 minutes. But the culmination of this, when it comes to trying to use the probabilistic information, this is the way that I used it today. So we know a big pattern change is coming. We've been on the cool side for the better part of May. We've got an anomalously strong ridge with strong ensemble support. We know we've got deep warm advection and moisture advection as well. It's unsettled, which we're welcoming up here. We are in D1, D2 drought, so we need some rain. So that's certainly something we want to focus on, is those rain chances. And then we dive into it further, the temperature potential. Coming into the week, you know, you've probably seen the CPC guidance, the 8 to 14, the 6 to 10 day showing strong above average. The SIPS guidance actually gets us a little more detailed in that. You know, our normal highs are, you know, upper 60s this time of year, late May for Madison and Milwaukee. And you've got a strong signal for above average and greater than or equal to 80 degrees from the SIPS analogs. So, you know, we're well above average. This is a strong signal, strong ensemble support. Then we get to that probabilistic NBM. We see that it's much higher. We talked about how it was suspicious and needs some investigating. 50% of our members forecasting at or above records. Unusually tight box and whiskers, which for me is always a telltale sign that, you know, are we dispersive enough? That should be you always come at it with some skepticism. If you think the ensembles have all the answers, it's still possible you can get sucker punched with something like this. But it's usually explainable. And that's where you test the conceptual model. We've been dry. What's my 29, 25, 850 temps? In these parts, southwest winds, temps overachieve. You get a southwest wind here, you can add 2, 3, 4 degrees due to increased mixing potential. But on the other end, do we have convection and cloud potential? So putting all of these pieces together and seeing the data, do the records make sense? So then it comes down to the messaging. So we know we've got high confidence above average temperature. We could probably go as high as we can with that. There's strong support. If you look at the probabilistic NBM and then looking at model certainty to provide that extra layer of context, you can pretty much say there's an 80% chance of having temperatures greater than 80 degrees. and about a 50% chance of greater than or equal to 85. So this is excellent information that you can message in that way. Obviously, if 80 and 85 were perhaps more vital thresholds, but you can think of it in another context of, say, 32 degrees, if you're talking about something from the winter season, or a heat index potential, or 90 degrees, or something that is, from a summertime perspective, a heat index or a heat concern, where certain thresholds are going to be, and being able to explain things in that probabilistic sense. There's a 50% chance of being greater than this threshold, which is a big deal. This is where we're considering a heat advisory. We're potentially going to an excessive heat warning. That's where you can provide a lot of excellent context, as opposed to the more deterministic language that we've been using more often in the recent past. So looking at all this information, certainly the chances of mid-80s are pretty good. The upper 80s and 90s are plausible, given our background conditions being dry if we don't get that rain and cloud cover, but we don't have enough to support those higher temperatures from the probabilistic NBM. And knowing what we know now, we have that kind of in our toolbox to say, okay, we know when we get into that changeable season, and we know we've been running high on the bias, and we flip that pattern 180 degrees out of phase, we should expect the probabilistic NBM to be a little bit higher than what is plausible. And not only that, as a consequence, it's probably also under-dispersive. It's been forced to an under-dispersive nature. That's why looking at the entirety of the ensemble information, and Andy showed earlier, the weather bell, looking at your GEFS plots, your ECMWF plots for temperature and things like that, they're going to give you that extra layer of knowledge that's going to say, you know what, that NBM probabilistic information, we need to add some value to that to make sure that we're dispersive enough to understand what's going on. So coming down to brass tacks, if I'm talking about doing something in GFE, if I'm going to make a change, actually at this point, I'm really not. The deterministic NBM is right in the mid-80s. We're in really good shape. No change is really necessarily needed, but you can message that, hey, we've been dry. If we get those southwest winds and very little cloud cover and better mixing, we could add a few more degrees to that. We could be upper 80s. Now that may give you extra things to talk about from a fire weather perspective. We've had those concerns up here. We've got that's been an issue that's been plaguing us here for the past couple months with near red flag conditions, and so it opens the door to discussing those things and those potentials. But again, you can use that probabilistic information to say, okay, if we do mix this high, we have this chance of exceeding a dew point threshold, or an RH threshold, or a wind threshold, as was discussed a little bit earlier. So that's how I interpret all of this. And I wanted to let Jerry back in here as well, since he was kind of my right-hand person to help me out with this earlier in the week, to kind of take this and then relate it to what we were talking about in those earlier slides that Andy was talking about. So Jerry, if you're still on, if you want to unmute yourself and provide a few more things that you were talking about.
Sure, I can do that. So would it be possible if we go back to, let's go back to slide 11. So I know some of you might still be asking, okay, so you've explained, a lot of what's going on in the NBM, but still, why is the deterministic so much different than what the probabilistic is saying? So, I think if you think about it as to how they're made, I brought us to this slide because what this is showing is a lot of the models that are going into the probabilistic are the ensemble members. And what do the ensemble members have? They have a whole lot less resolution. So they're at a much higher resolution than what a lot of these deterministic models, of which we see in the in the more deterministic side of the NBM. So when you start bias correcting those models, the bias correction is going to really hit those ensemble members hard. The reason why is because it's going to be trying to do a lot of this the topographical influences there. So it's going to hit those hard and have some pretty dramatic impacts on those. And those are going to be driving that probabilistic data set quite a bit. So, you know, just that alone, I think is going to be a pretty big impact. And I think that's also why we're seeing some of those tighter spreads that we're seeing, because when you have that many ensemble members getting impacted that largely, it's going to have a pretty dramatic impact on the overall system and really affect the spread of it. Now with the MBM deterministic, you know, you have models that are, you know, more different from each other. And also you have this point blending technique. So every single point in the whole country gets its own distribution. So it gets its own model weighting setup. And when you get that own model weighting setup, if you have a model that is performing, you know, very well, and maybe that model didn't even have a strong bias, so say the European, it only had like a 1 degree bias and maybe it was on the cold side, it's only going to really impact the overall distribution, you know, a very little bit. So, you know, that point blending, I think, really can impact, you know, a major difference between the two. So, you know, I know that it's somewhat of a wishy-washy answer still, and some of you still might not be feeling very comfortable about it. But the idea here is these two systems are very different from each other. They're using similar models, but the way they're computed is still pretty different from each other. You know, there's, like has been said a few times, they're still doing a lot of work with the probabilistic side of the MBM, and having the information is more important than not having it. So getting it to us is still offering us a lot of information about the overall system, all of the models that we have. It's still offering us that system. And there is discussions about maybe not including all bias corrected models and throwing some raw models in there. Those discussions are being had. Obviously, they have to consider some of the mountain impacts if they do that, because having a 20-kilometer model, you know, might completely wipe away some of your model or your mountain influences. But, you know, there's lots of discussions being had, and they're going to try to update this system for, you know, the 4.1 version once they get all the computer updates done. And, you know, 4.2 will have even more information to us. So the system will get better. There's no doubt about that. But, you know, it's good for our forecasters and good for people right now to know that these two systems, the deterministic and the probabilistic, they're very different systems right now. So, you know, I just wanted to hit that a little bit more so people understand that and maybe can, you know, take that with them. It doesn't mean they're going to always be showing completely different answers. There's going to be plenty of times, you know, especially when you get into the, you know, under a big high pressure ridge in the winter time for, you know, weeks on end, or, you know, during the summertime season. I think MBM will really hit home and do really well during that warm season time frame. And once we get out of this spring season where you're having these ups and downs, you'll see the deterministic fall back in line with what the probabilistic looks like. It's just the nature of the beast right now that we're in. When you're in the transition periods, it's just going to be this way. So I'll pass on the torch to whoever wants to talk, or if we want to open it up for more questions, that's fine too.
Thank you, Jerry and John, for both that great insight on all of this. I think you wrapped this up beautifully. So I'm gonna head towards the end of the presentation here, and then I want to open up some discussion out there. So you know, we've covered a variety of different tools on here, from the EFI to the MBM 1D viewer and stuff from the WhatsApp viewer and that. So you can always access all these tools and more off our STI Google Sites page. We've you know, and we've tried to add some things on there even lately from the last talk. So again, check that out when you have a moment, if you haven't already. And again, let's open this up. Do you have any questions? We can certainly look at your specific area if you would like, and talk about talk about what's going on with respect to MaxT, MinT stuff and in the MBM. You can either use the, you can chat a question in the question pane. I'll keep monitoring the list for any question. If you have a hand raised, I can open up that way.